All right, can everybody hear me okay? So I'm remote desktoped into my computer through the phone, so if it flakes out, that's probably why. All right, so tonight's talk is OAuth 2 OpenID Connect with Identity Server 4. We're going to kind of give a high-level overview of what OAuth is, a little bit of OpenID, just from a standard protocol standpoint, and then dive into the specific implementation of that in the .NET Core called Identity Server. And then I'll also give a few examples of various clients that could authenticate against Identity Server and how to set that up. One of them being an Angular SPA app. Given a code example of a Xamarin app, and you guys can kind of extrapolate other clients from that. So a little bit about me. Been developing web applications professionally using Microsoft technology for over 10 years. I'm the founder and solution consultant at Linkstream. And Linkstream is an IT consulting custom software shop. We focus on Microsoft, web, blockchain, and mobile technologies. And we're based here in Omaha. I have some cards on the desk back there with empty pizza boxes if you want to get in contact with me. Email is probably the best way. If you need help with any projects or just want to talk, feel free to reach out. I've done several projects with OAuth. When we do custom projects, it's kind of the standard login mechanism that we use. So that's what spurred this talk. Okay, so what is OAuth 2, second version, and OpenID Connect? So OAuth is an open standard for access delegation, commonly used as a way for internet users to grant websites or application access to their information on their websites, but without giving them the passwords. And OpenID is an open standard and a decentralized authentication protocol. OAuth is a service that is complementary and distinct from OpenID. However, OAuth is directly related to OpenID Connect since OpenID Connect is an authentication layer built on top of OAuth 2. And I've included a couple links to RFC and documentation if you want to really dig into what that is. So it's a standard, and there's different implementations of that standard, one of them being Identity Server. And I can give the slides, I don't know, in the Slack channel or something, probably, if you want to get further into it. Okay, so what are the benefits of OAuth? You have API level security, federated identity, service monitoring, fine-grained access on clients to resources, easy third-party integration with resources, and limit access to who needs password credentials. That's from a high level, some of the benefits of OAuth. I'm going to go through just a few pages of definitions before I get into it in more depth, just so we can be on the same page as far as terms and what exactly I'm talking about. So authentication versus authorization. You probably heard this before. Authentication is a process of asserting that someone really is who they claim to be. This is what OAuth does. So for example, I am Thomas. My email is tom@linkstream.com. Those are claims about who I am. That's authentication. Authorization refers to rules that determine who is allowed to do what. So for example, Adam may be authorized to create and delete databases, while John is only authorized to read. So this is authorization. This is what an identity has rights to do with a particular client. And that's the domain of OpenID. Some more definitions. You're going to hear a lot about tokens. There's different types of tokens. I'll get into a little bit more of like what they are, their format, things like that. But you have an access token. This is a token used to access protected resources, generally some sort of API. A refresh token is a special kind of token that can be used to obtain and renew an access token. Authorization code is another type of token. It's an intermediary token generated when a user authorizes a client to access protected resources on their behalf, and the client receives this token and exchanges it for an access token. We have an authorization server. Bear with me, I'll have some diagrams that kind of flesh this out a little bit, but an authorization server, a server which issues access tokens after successfully authenticating a client and resource owner and authorizing the request. You have a client, an application which accesses protected resources on behalf of the resource owner, such as a user. The client could be hosted on a server, desktop, mobile, or other device. A grant is the method of acquiring access to the token. A resource server is a server which sits in front of a protected resource, for example, tweets, user photos, personal data. It's capable of accepting and responding to protected resource requests using the access token. You have a resource owner. It's the user who's authorized on an application to access their account. The application's access to the user's account is limited to the scope of the authorization grant. For example, read and write. Scope is a permission, and then you'll see JWT or JOT token. This is a JSON web token. It's a method of representing claims securely between two parties, and there's another RFC if you really want to have a fun weekend reading about that stuff. So OAuth generally defines 4 roles. So you have a resource owner, which usually is a user. So for example, I would be the resource owner. A client is the mechanism through which a resource owner authenticates and accesses protected resources. So a client would be something like a mobile phone, maybe desktop, my laptop. The resource server is the server that has the protected resources on it. So let's use the example of Google. I'm logging into my Google account. I'm the resource owner. My client is my phone. When I'm accessing my email resources, I have to first go to Google's authorization server, get authenticated, and then the combination of me as a resource owner and the particular client that I'm logging in with, I'm given a scope or set of access to that resource. Here's a diagram found on the internet, kind of high level if you're more visual how this all works. So again, the resource owner or the user down in the bottom left, they have a client application. So imagine up here is kind of, this is the client. So this would be like the phone, for example. So I'm trying to access a resource service. The first thing I need to do is hit the authorization server. It authenticates, and then the resource owner grants access. The authorization service issues a token to the client in certain flows. Other times it issues it to another layer. But it issues tokens, and then those tokens are used to access the resource servers. This is one example. OAuth is actually pretty open, so this is an example of a user. You could also have an example of a server being the resource owner, and they're accessing the identity server, getting a token, and then they're able to access other resource servers. So it's really multi-level architecture. And it really plays well into like enterprise setup. So the OAuth 2 specification, it's flexible authorization framework that describes a number of grants or methods for a client to acquire an access token, which represents the user's permission for the client to access their data, which can be used to authenticate the request to an API endpoint. Basically what that's saying is you see this flow here where the user is accessing the identity server, tokens are being issued. There's different flows in exactly how that happens, and we'll get into a few of those. And specifically, it describes 5 grants or acquiring access tokens or flows. You have authorization code grant, implicit grant, resource owner credential grant, client credential grant, and refresh token grant. There's a link in here. I'll probably show this a little bit later, but kind of a little bit deeper dive into some of the differences between those. So I'm not going to go through all of them. I'm going to go through a few of the most common ones I've used and explain why you'd use them. So the first one is authorization code. So in this scenario, think of having a like a traditional ASP.NET web app that has a server-side code that can manage state and things like that. So the resource owner, or the user in this case, is going to authorize a request, and the user authorizes through an application, through their user agent, which in this case is a browser. The user authorizes that application, and then the identity or authorization server is going to send a code, an intermediary token, to the application, which it's then going to hold on to that. And then if it needs to access a new access token, it can do that later on. So it kind of handles that state. So the user agent, the browser, never actually gets the access token. It's sent back to the client application, and then that accesses the protected resource servers. Now, you can't obviously use that like in a SPA application because there is no backend in that sense. So one of the examples I'm going to show is an Angular 2 SPA or Angular 5 or whatever it is now. And it's going to use an implicit flow type of grant. So in this case, you have user authorization request. The user authorizes the application, and it's redirected back to the user agent or the browser at that point. And then at that point, the browser actually manages the access token to the application or other resources that are protected. Does that make sense? It's kind of a subtle difference, but it's kind of about who's managing the access token versus intermediary token. In real-world example, basically an implicit flow, the browser is going to get the access token, and they're going to make requests with that. In the other model, it's going to go back to like there's going to be a code, like a token that's used to get that access token. There's kind of some security implications for that. Technically, authorization code flow is considered more secure because you're not sending the access token across to the user agent. One other type, client credentials. This is where the actual client enters the credentials. So in those other two flows, the client doesn't need to know what the password or username is. So for example, if you have a third-party app that's logging in using Google, it doesn't know anything about your Google password. It just kicks you over to Google. You log in through Google's identity server, and then Google authenticates you and then kicks you back with a token to then access resources potentially on Google servers. On this model, the client actually knows the username and password, and it passes the client credentials to the authorization server. And then there's similar flows after that. So that's the subtle difference there. Of course, once the authorization server gets the client credentials, it sends back an access token. This says with no refresh token. A refresh token is kind of a longer-term token that can be used to refresh the access token, because usually on an access token, you're going to want to have like a short timeout or lifespan of that access token. Okay, so which OAuth 2 grant should I use? A grant is a method of acquiring an access token. Deciding which grants to implement depends on the type of client an end user will be using and the experience you want for your users. So, if you want sometimes you don't want the user to be kicked over to a third-party service and have to log in there. Again, this is just saying, depending on what the experience is and some of your needs. This is a little flow chart. Might be kind of hard to read, and this isn't like you have to do this. This is kind of more, I would say, recommendations or guidelines. So the first question you ask is, the access token owner. Who owns the access token? Is it a machine or is it a user? If it's a machine, it goes to client credential grant. If it's a user, then you ask, what type of client is it? Is it a user agent client, like a browser, or is it a web app that has a backend server, going back to the previous flows I mentioned? If a web app, you're going to authorization code grant, again, because it's a little more secure, technically. If it's a native app, if it's a first party or third party, if it's first party, you can use password grant because you're the first party, so you can know the password. Otherwise, you'll want to go to authorization code. And then if it is a user-based app, user agent-based app, is it first party or third party? If it's first party, again, you could use password grant. In the example I'm going to do, it is still first party, but I'm still using an implicit grant. That way I can have multiple apps within my enterprise that all use the same login screen. I don't have to recreate that on each client. Again, this is not necessarily what you have to do. It's just kind of something to help make the decisions. I know when I was first looking into this too, it kind of seems overwhelming, like, why is it so complicated? But once you get it, it's not as bad as it sounds, but it just provides a ton of flexibility, a ton of, especially like an enterprise environment for managing logins and access to resources. It really is well thought out. Okay, so I talked about some of the tokens, the JOT tokens or JWT. Again, here's the RFC link for that if you want to read that. They generally have three parts: a header, a payload, and a signature. The header identifies which algorithm is used to generate the signature. It looks something like this, so some kind of encrypted signature. The payload contains the claims, basically who is it, the metadata. And then the third part is the actual signature. So these tokens are being signed. I mean, that's how it's secure, so you can't just create a token. The resource server is going to know if the token was signed by an authority that it trusts. Here's just kind of a little diagram. The JOT token is usually like base64 encoded, and then if you decode it, it's separated by periods to separate the three sections I mentioned: the header, payload, and the signature. And I'll show, when I do some of the code examples, I'll show there's a couple of cool online utilities where you can paste in your JOT tokens and it parses them and kind of shows you what's going on. OpenID, I'm not going to talk a whole lot about this for this talk, but basically just understand that OpenID is built on top of OAuth, and it's more about access. So it has more advanced things with claims and things like that. OpenID just has another layer, another flow, and another token that's used to manage that. Included a link here to some details about like the structure of those tokens and things like that. So I'm going to kind of just leave it at that. So when I get into Identity Server, just know Identity Server manages OAuth, and it also does OpenID. So I'll touch on that briefly as well. So, okay, what is Identity Server? Talked a little bit about that. We talked about the OAuth OpenID standards. So Identity Server is an OpenID Connect and OAuth framework for ASP.NET Core 2. So some of the things it provides: authentication as a service. It's a centralized login logic and workflow for all your applications, web, native, mobile services. Identity Server is an officially certified implementation of OpenID Connect. It allows you to do single sign-on in and out of multiple application types. Access control for APIs. You can issue access token for APIs of various types of clients, for example, server-to-server, web applications, SPAs, native and mobile apps. It's a federated gateway, support for external identity providers like Azure Active Directory, Google, Facebook, etc. This shields your application from the details of how to connect to these external providers. It's focused on customization. This is kind of a really big point. The most important part: many aspects of Identity Server can be customized to fit your needs. Since Identity Server is a framework and not a box product or SaaS, you can write code to adapt the system the way that makes sense for your scenarios. So what that's saying is, it conforms to the standard, but it provides a ton of configuration interfaces and different ways you can configure it. Data stores, how are you storing user credentials? I'll get into some of that. But there's a little bit of a learning curve as you get into it because it is kind of so flexible. But it's also very powerful. So that's kind of the trade-off with anything. Mature open source Identity Server uses a permissive Apache 2 license, allows for building commercial products on top of it. It's also part of the .NET Foundation, which provides governance and legal backing. It's free. There's free and commercial support. There's like forums and Stack Overflow articles out there, pretty easy to find a lot of information on it. There is some commercial support you can buy as well, or you could just call me. Okay, so some of the code examples. So, is that too small? Okay. Bigger, or is that good? I'll take that as bigger. Okay. Got some notes on this part. So this is the .NET Core 2 project that actually implements the identity server part. So if you remember that diagram, there was the resource servers, the client, and then the identity server. I think that was on the bottom right. This is that identity server or that authorization server. So you can just create a .NET Core app and pull in the NuGet package for identity server. It's version 4, I think, is the current version. So you just, first thing is install that NuGet package on your .NET Core app. And then first thing is startup. I'm assuming you know something about .NET Core. I'm not gonna go too deep into that, but basically, when a .NET Core 2 app starts up, there's a couple life cycles that run at the beginning for configuring services, configuring the hosting environment, things like that. Because obviously, .NET Core can run on Windows or other environments as well, so you have to configure some of that. But basically, Identity Server ties into the pipeline that fires. So on this configure services, you have to add Identity Server. You can add some options here. I'm adding an extra token or part of the URL that goes back because when I get into the Angular client, it required an additional flag here that isn't out of the box. Here's where you configure your API resources. As we talked about, the protected resources, you set them up in Identity Server. And again, it's very flexible. You can load them from anything. You can load them from a database, Mongo or SQL Server, from file, whatever, in memory. In this example, they're just in memory. The same thing is with your clients. So you could have multiple clients. Say you have several mobile apps and several applications in your enterprise. You can load all that from a database. Again, I'm going to do in memory. There's signing. In a production environment, you use some kind of certificate, but this is just for development. You can use, it has like a built-in development signing credentials to make it easier to get off the ground without having to set up all that infrastructure. And then you could, of course, in .NET Core, you can do like on is development, you could use your developer credentials, signing certificate versus in production. That's really helpful to getting off the ground quickly without a bunch of monkeying around. So. And there's just some more configuration here, identity resource in memory. And then also on the application, you have to call use identity service. My identity server is going to have some UI. So out of the box, it doesn't come with UIs. You have to create your own logins and registration screens and things like that. So I'm using MVC. Added that to the pipeline as well. Okay. So API resources, we'll do that one first. Okay, so API resources, this is a class provided by Identity Server. And basically you're just defining all your resources. Imagine in your enterprise you have all different types of services. You list them out here. In this example, I only have one. This is a project, it's like an internal CRM that we use, but that we built. Axiom.api is the API. Here's the clients. Again, this example only has one client, but which is the SPA. and you have to give it a client ID, a name, so what type of grant that it's allowing. In this case, it's implicit, but you can see this enum. Oops. This isn't my computer, so bear with me. Identity Server provides a bunch of different grants and also some hybrid grants. So you may want one client to be able to get access tokens through various types of flows. This one is set up for implicit. Then you set a lot of other configuration, like the redirect URLs, what URLs are redirecting back to, post logout URL. You can set some things with CORS. Require consent. I have this set to false, but by default it's true, and actually it's going to route you to another consent screen. I don't know if you've ever logged in to an app with Google or Twitter or something, and you first log in, and then it sends you to another screen and says, this app wants to access your photos and your whatever else. What that's requesting is scopes. It's saying, these are the scopes that it's requesting. That's considered consent in OAuth, so you can turn that off, so mine just logs you in and kicks you back, but it could log you to another screen where you have to consent to specific scopes. There's a client secret, and then there's allowed scopes, like what scopes are you allowing this client to have. So maybe when you're accessing it through a mobile app, you don't want them to have access to photos for some reason. You can drill down and lock down the scopes for a particular client. And again, you could load this, I know this is all hard-coded, but you could load this from a database, anything else like that. And this is where the real flexibility comes in. Okay. User controller. So let's pull that up. So here's my controller I created. This is just your typical MVC controller, and it has the things like your login screen, and then you post a login model back here. And what it does basically is you can authenticate however you want. You could just return true and authenticate anybody if you wanted to. Once it does that, then it's just going to, depending on if they select the Remember Me, it's going to set the time if it's persistent cookie, and then sign you in through the .NET pipeline, which is going to be using Identity Server, or however you configure it. This will just create a cookie on the Identity Server if you have a Remember Me that doesn't expire for a long time. And then if your app you reload the page, it's going to kick you over to Identity, see the cookies there, and automatically kick you back. So we'll see. I'll show you that. So yeah, that basically logs you in. Again, this is out of the box. You don't get any of this. You have to create your own login screens, your own registration screens if you want them, your consent screens, how you log in. It's totally open to you how you do all that stuff. OAuth is just a standard way of interacting, so that's kind of something you got to wrap your mind around. So we talked about consent scopes. Resource owner password, that was one of the last flows I think I talked about. This uses, this is the interface that you have to use for that particular flow. It's not implemented, but again, these interfaces are all provided by Identity Server. Real quick, I'll talk a little bit about OpenID Connect. So there's kind of standard URLs that all these endpoints are going to hit. One of them is going to be your profile service. This code here that uses this iProfile service interface, you create your own custom class, and this is going to get called by OpenID, and this is where you can set all your claims. So in this particular example, I'm setting the claim type of name, to the identity name. I'm setting up some of the role claims, even though some people argue you shouldn't put that in claims, but and some other stuff. We have a site, like a multi-tenant site claim that we use. But this is going to get called by OpenID Connect, and then this is more for your authorization side of things. And again, it's an interface provided by the framework. Same with some of these classes like claims. This is going to be part of the .NET framework, claim types, this is kind of beyond the scope of this talk, but you can configure definition. You can configure all types of different claims. This is a Microsoft thing, so a lot of people hate this, but I think it's a holdover from some older technology. Okay, that's high-level identity server. Any questions about that particular part of it? Okay. So now onto the protected resource, or the API, right? So this is the server that you get kicked to by your client to log you in, and then it's going to kick you back to your client, and now your client has this access token, and it's going to access some resources. So this next bit of code is going to be the actual service that's being protected. Again, it's another .NET Core app. You can use like a regular .NET app. There's a little bit more work you have to do. You know, it's kind of like you have to hand code it basically to parse the bearer token and all that stuff. But if you're using .NET Core, it's pretty slick because it's all just set up for that out of the box. You have to just, let me zoom in on this guy. You have to add authentication. This is the name of the token. There's some identity server options. So what's the authority? Basically, what's the trusted authority? In this case, I've set up some localhost redirects here. So identitylocal.axiom.software is my identity server. What's the name of the API? If you remember back in the other code I was just showing, I created an API with the same name. All this stuff has to match up. Otherwise, it's not going to work. And it can be tedious if it's off by one little character. A couple other options. You can say what claims are you going to define as your role claims. And then it automatically, like into the .NET Core code, like if you say is in role or attributes or things like that, it's going to know what you can configure what the claim is that's going to actually define roles. Same with name, so the user identity name, so that's what that is. Let's see. And I think you have to do this, use authentication as well. You would normally, since we're just using the developer credentials, you'd have to configure some of like the signing certificate and stuff like that in production as well. Let's see. So how does that work for controller? Just like it always worked. You put your authorization attribute on your controller, and it locks it down. Some of the ways to access claims, I would just show like here, context, HTTP context user claims. You can grab all these different claims, and it's gonna parse that JOT token as it comes across, and then it's gonna know what all those claims are. Okay, here's one. This isn't necessarily OAuth, but it's kind of related. It's a pretty cool feature of .NET Core. So you can set up what they call policies. On an older .NET framework, you had your authorized attribute, right? And then you had is in role attribute, and you could put that on a controller and control that resource with that role. With this, it's actually quite a bit more flexible. You create these policies on startup. So for example, I'm creating this admin policy. And I can set all types of rules for that policy. So I can say the user is required to be logged in. Okay, it's obvious, but maybe not. Required claims, I'm going to require a role claim of admin. And you can just extrapolate from there. You can have all kinds of rules and conditions in this particular policy. And then on your, and again, this ties all into the identity server token and everything. On your actual controller or on your controller method, you put this authorized, and then you define this is the policy that I want to restrict for this resource. So you can get some real interesting combinations rather than just roles, you know. And the nice thing about this, if you have this sprinkled throughout your code and you want to change it, you just come and change this policy in one spot, and then everything that subscribes to that policy will then have a new set of rules for authorization. Okay. Any questions about securing the resource? Okay. So a couple clients. Let's talk about Angular. So this is Angular 5, 6, whatever the latest Angular is, client. So this is a pure SPA. There's no .NET application. It's just JavaScript, HTML, and CSS. And it's going to authenticate against Identity Server. I have it set up to automatically do that. So if you're not authenticated, it's going to kick you over to Identity Server, log you in, kick you back. And then it's going to use that token to access a .NET Core API. So a couple things you need to do. Again, OAuth, OpenID are standard, so there's tons of libraries out there. Pretty much anything, like if you're working in Java or Ruby or whatever, I'm sure there's gems and packages for OAuth. That's kind of the nice thing about it. So Angular has several, of course, and the one that I've used and had the most success with is this Angular Auth OIDC client. So let me zoom in on here as well. Is that too small as well? There we go. So add it to your NPM package and NPM install. Then there's some kind of funky setup you have to do on your app module. Is everyone here familiar with Angular? Some people? Okay. This could be any JavaScript framework, potentially. This is just a particular implementation. So on this one, you have this load config method that's actually going to call out to your identity server. There's a specific endpoint in OAuth that pulls back the configuration for the identity server. And then on your providers here, you have to pass this in. There's some other settings you have to do to kind of bootstrap things before Angular really gets going. And I also have this constructor that calls into this guy. And what this does is just sets all the configuration for your client. So you can see my client ID, axiom.app. If you remember back in the identity server, that was defined as a client. Here's the response type. Here's the scopes I'm requesting. And again, I configured what scopes were allowed to be requested. There's other settings, post login redirect, silent renew. So one of the things silent renew does, because it's a SPA, it has something in the background that constantly goes back and gets a new access token after the expiration time is getting close. Just a bunch of other stuff, logging settings, all different types of stuff. And all this has to match up exactly what's in the identity server. Otherwise, it's not going to work. So, your app component, this is the auto login part. Basically, all this is doing is saying, hey, if they're not logged in, then kick them over to this auto login component. And then when it's done, hit this callback. And it's basically just, this is some custom code that's just going to redirect them back to the page that they requested. The auto login is just going to call into that NPM package, authorize, and it's going to kind of handle all the specifics for you. So let me show you what that looks like. So this is the SPA app running on my local machine. You can see in IIS I've got several things set up. The first one is going to be the actual app itself. So these are all like subdomains, app.local. Thought I had that closed. Was that on the other computer? Oh wait, that's on this computer. Okay, should I close that for you? So app.local is the client. I have the API running under here. That's the .NET Core app. And then I've got a couple other apps running. And then here's my identity service. that's running on identity-local Axiom.software. So I'm going to log out here. So now I'm going to go to app, local, Axiom software. That's the client. I'm not logged in, so look, watch the URL bar. See how it kicked me back to the identity server? It's kind of hard to see, but there's a big, huge, long query string up there. That's all the information that was sent back to the identity server. Like, here's the client, here's the redirect URL, the callback, all that sort of things. So then I get logged here to my identity server. Now notice I didn't check the remember me, so there's no cookie here, my persistent cookie. So I'm going to click login. It's going to log in against my database, and then notice it kicked me back. This is some multi-tenant stuff that we added, but and now I'm going to make an API call here. What I want to show you is on this API request, there's an authorization bearer token, and there's this big encoded string. If I take this, paste it into here, that's going to parse the token. And if you remember from earlier in the talk, there's the header with the encryption information. Here's all the payload. So some of this stuff, these are used for like, it's like nonces and stuff, so it doesn't, you can't fake it, and expiration dates. But here's the client ID. You can see the claims that were added. So here's some of the role claims, user ID claim, site claims, and this is all customized. Some of this is customized. And then here's where if you put your certificate in, you can decrypt it. So how'd that get in there? That was also some Angular code. Created a base service, so all my Angular services inherit from this, Angular data services, and I'm just setting the header. I'm able to get that token from my OAuth service, which is just an abstraction over that NPM package, and then I add the bearer token as a header, and then that goes across all my API requests from my SPA client, and then my protected resource knows what to do with that. So that's how I lock that down. Let's see here. Okay, let me show you one other thing real quick. This is just a link you might want to look at. That's a link to the NPM package that we were just looking at. Oh, this guy. Yep. Actually, a couple links I'll show you. This link here is the OpenID token. This is a link to the .NET Core policies stuff I was talking about briefly. This link is pretty good. It has a bunch of stuff. So this has some of the that big long URL for the different flows. It kind of breaks down what the sections of that are, what they do. I'll include this link. There's one from DigitalOcean I took some of those pictures from. This is the NPM package for Angular to use OAuth. I'll include all those in there as well. Okay, so that was a SPA client. I had a Xamarin app working, but for some reason the VM, there's like a 40% chance I'm going to get a blue screen of death on this Mac. So I decided not to risk it. But this code works, just trust me. So it's really simple because OAuth and OpenID are open standard. There's tons of libraries, as I was mentioning before. There's one for Xamarin, OAuth 2 Authenticator. And it's kind of the same thing, basically. I'm setting up my client name, my API resources I want access to, my identity server location, and there's just an event that happens, and then when it's completed, it fires back here. And this code here actually is getting me the token, that bearer token that you saw in the client app. And then I can use it the same way here. If I'm hitting a REST API, my Xamarin app can use the bearer token on all my HTTP requests to the protected resources. And then think about the other aspects. That's just a mobile app. If you have a Java client, same thing. You could have maybe some servers in your enterprise that you want to authenticate, and now everything is hitting the centralized service, and nothing really needs to know about the passwords or anything except that. And then it's really simple to tie in like third party. If you want to log in with Twitter or some other third party, that makes it pretty easy for that. And then you could also, if you have an API, you can allow other parties to log in against your service and access resources within a certain scope in your infrastructure. So it's pretty powerful, pretty configurable. There is a little bit of a learning curve, but once you get it, and I'm still learning about it too. So it provides a lot of flexibility and power. So, and if you're going to start an app from scratch, I would use it for your authentication. It makes it pretty simple. That's pretty much all I got. Unless you guys have questions.
So the web APIs that you have, they have to authenticate against the authorization server, right? So every time a request is sent to one of your web APIs, how does it know that the token is valid?
Yeah, that's part of the signing of the token. Because I kind of mentioned I was just setting up the developer credentials, but you usually have some kind of certificate that would be shared on your resources. You can kind of see in this diagram.
So that certificate has to be distributed.
Potentially. It's very configurable. There's an interface, so you can configure how JOT tokens are authenticated, but it just uses encryption. There has to be usually some kind of key on the protected resources that can say, hey, we know this was generated by this private key or something like that.
Yeah, I was just wondering if every web API has a copy of that key for it. With every request, you have to go back to the authorization server.
Yeah, you can configure it to kind of do it a lot of different ways, but it does have to authenticate that this is a valid token that wasn't corrupted or sent from an untrusted source. That's part of the signing of the token. Do you have a question on that?
Yeah. So when I worked with identity server in the past, one of the big things that we run into is difficulty because of security focus, it doesn't expose a lot of information when you do that in cloud. Is that your experience?
To a certain degree, yes. One of the things, it's kind of a pain to do, but if you go into the wherever you're hosting your identity server, and turn that to true, it's pretty verbose in what it spits out, but that's kind of what you get is those log files. Yeah, I mean, I think it's pretty, they do log out quite a bit, and I've usually been able to figure out what it is by going into those log files, but yeah, it's kind of tedious to dig through them.
I know it's a lot better in Identity Server 4 than it was in 3. If you set your tracing level to trace and then dump it to the console, you get a lot of feedback almost immediately. If you run the local machine.
Okay. Anything else?
So is it easy to have identity authenticate to like an Azure Active Directory?
Yeah, it kind of, yeah, it comes with a lot of the plumbing to go against different third parties like Google, Azure Active Directory. And you can have multiple identity stores too. You could have your own proprietary identity store in multiple third parties. It's very configurable. Multi-factor? Not that I know of, but again, you're creating all your own screens, so you could, it's just an MVC app at that point. You could create however many layers of authentication you want. You could require them to have a second factor before you authenticate them. But that would be more custom code. I don't think it, I could be wrong, but I don't think it comes with the identity server out of the box. Thanks, guys.